Hello everyone. In this video, I will be talking about oscillations introduction. Oscillations are due to repetitive periodic motion. In this figure, we can see a pendulum. In this, the motion of the pendulum is repetitive. That is, the pendulum moves to and fro about a mean position, which is at the center. So any motion which repeats itself at regular intervals of time is known as periodic motion. If a body moves back and forth repeatedly about its mean position, then it is said to be in oscillatory motion. Now in oscillations, the frequency of vibrations is comparatively less, as we can see in the case of a simple pendulum. Other examples include the swing. In the case of a swing also, it is in periodic motion. Now vibrations are defined as movement of object about its mean position, and this motion can be linear, circular, periodic or non-periodic. The difference between oscillations and vibration is that the frequency of vibrations is much higher than that of oscillations. Now every oscillatory motion is periodic, but every periodic motion need not be oscillatory. Circular motion is a periodic motion, but it is not oscillatory. For example, the motion of Earth around the Sun is periodic motion, but it is not oscillatory motion. Now, simple harmonic motion is the simplest form of oscillatory motion. In this case, the force on the oscillating body is directly proportional to its displacement from the mean position, which is also the equilibrium position, and also directed towards the mean position. The force will be directed towards the mean position. After some time, the swing comes to rest in the equilibrium position. This is because of the dissipative effects of friction. Oscillating bodies eventually come to rest at their equilibrium positions. This is because of the damping due to friction and other dissipative causes. They can be forced to remain oscillating by some external periodic agency. For example, in the case of a swing, we can push on the ground with our feet to keep the swing in periodic motion. It is an example of a forced oscillation, and the action of us pushing with legs on the ground is an example of external periodic agency. Now, any material medium can be pictured as a collection of a large number of coupled oscillators. The collective oscillations of the constituents of a medium manifest themselves as waves. And these examples of waves include water waves, seismic waves, electromagnetic waves, etc. So oscillations produces waves. Now we shall see period and frequency. The smallest interval of time after which the motion is repeated in case of a body which is in periodic motion is called its period. It is usually denoted by capital letter T and its SI unit is second. The reciprocal of number of repetitions that occur per unit time is called frequency of the periodic motion. It is usually denoted by nu and its SI unit is hertz. Now displacement. In oscillatory motion, displacement refers to a change with time of any physical property under consideration. The displacement variable may take both positive and negative values. In experiments on oscillations, the displacement is measured for different times. In the case of a spring which is fitted to a wall, the displacement is taken as the change in position of the spring from its mean position. In the case of a pendulum, displacement is the angular displacement produced in the pendulum. While in the case of a AC circuit, displacement is the magnitude of the oscillating voltage across a capacitor in the AC circuit. Now, a function returning the same values at regular intervals is called a periodic function. Any periodic function can be expressed as a superposition of sine and cosine functions of different time periods with suitable coefficients. And this is what was given by Fourier. Now we shall see simple harmonic motion in detail. We have already learned that simple harmonic motion is a periodic motion in which the body moves to and fro about its mean position. The restoring force on the oscillating body is directly proportional to its displacement and is always directed towards its mean position. Now, we shall consider a body moving between two positions minus a and plus a. And in the above image, we can see that the particle is vibrating to and fro within the limits negative a and positive a. Now, to study the motion of this particle, we have to record its position as a function of time. The position of the particle with reference to the origin gives its displacement at any instant of time. For such a motion, the displacement x of t of the particle from a certain chosen origin is found to vary with time as x of t is equal to a cos omega t plus phi. And the graph shows the variation of displacement as a function of time. Now the quantity A is called the amplitude of the motion. It is a positive constant which represents the magnitude of the maximum displacement of the particle in either direction. The time varying quantity omega t plus phi is called the phase of the motion. It describes the state of the motion at a given time. The constant phi is called phase constant or phase angle. The value of phi depends on the displacement and velocity of the particle at t is equal to 0. Now the constant omega is called the angular frequency of motion and is related to the time period t. And the relation is omega is equal to 2 pi by t. The SI unit of angular frequency is radians per second. So this is the end of this video. In this video, I have given an introduction to oscillations. If you have got any doubt in any of the concepts discussed in this video, please comment in the section below this video. Thank you.